Okay, this diagram basically it captures all of the notion of materials engineering. So this is a tetrahedron, and the tetrahedron has these three sides and then a base, so it has four sides total. And what it illustrates is that these different ideas are connected. So a material's performance is connected to its structure or composition, and it's also connected to the processing, which is, whatever sorts of things we may do to it, such as forging or heat treating. And the processing is connected to its properties. So when you're basically selecting a material, really you're selecting all four of these elements. You're selecting its performance, and you're selecting a structure, the properties, and the processing together. So this is the thing that we're going to explore this quarter, is understanding the relationship between these four elements, and then maybe even learning how you might manipulate some of them in order to get the performance that you want. Now, in terms of traditional materials, a lot of what we paid attention to were things like strength and stiffness and that sort of thing around materials performance. But nowadays there are questions about sustainability. How will we alter this whole materials life cycle in order to ensure sustainability of I guess of the civilization, if we think that's a good goal. Any case, the questions become different. Now the structure composition question is around, what is in that material that and what is the geopolitical profile of requiring that? What about the human rights profile? A classic example is, if you specify diamond, for example, natural diamond that has a very, arguably negative geopolitical profile. Then if you were to ask questions about the processing, you would ask a different set of questions. The processing may now cause you to say, what is the embedded energy or the embedded water or the environmentally just practices or unjust practices, I guess, that are in the way that material is made. And then in terms of properties, you might ask questions about what is the life cycle toxicity that is connected to these materials. So as you can see, there's a whole set of questions in addition to the engineering performance of corrosion resistance or stiffness or flexibility that you would also consider when you're engineering a material.